Now it's visible to all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Thank you for acknowledgement. So now we can understand about the complexity, we can understand about notations, we can understand how to calculate a complexity for a particular loop. So everything is clear?
Yes, ma'am.
Okay. That means you can attempt the question if someone gives you some code and you have to calculate the complexity.
Yes.
Yes, ma'am, we can try, but not too much practice we have done. So
you have to do practice, take some questions, calculate the complexity if you have any doubt. I saw some mathematical induction question on my mail. Some student completed the task and mailed me. Thank you for completing the homework question. You attempt very well. So it's my request to everyone, kindly do these things in practice. Not give all the time to these questions. Give at least 2 or 3 hours in a week.
okay, sure, ma'am.
So in the previous class, we completed this example. That means how to calculate complexity of a particular code in notation, right?
Yes.
We also evaluate polynomial. Now the further concept is matrix multiplication. And then exponent evaluation. So exponent evaluation is a very important part according to question paper. So let's start matrix multiplication. So how can we multiply two matrices? Is there any rule to multiply any matrices?
Yes, ma'am.
So
Yes,
what
ma'am.
is that rule?
In normal case, we have studied in our college time that first column and from first matrix and second from second matrix first row
This
multiply
is
and
a
add each.
method. Sorry. This is a method
Is
of.
that the number of column and rows should be equal in both matrices.
Yes.
Can you repeat your statement? Yes, you are right.
The number of rows and columns should be equal in both matrices that we are multiplying or dividing.
Okay. If two matrices are 2 into 3 and 3 into 2, they can be multiplied. But what is the reason? So the reason is very correct. That is, the number of columns in a first matrices should be equal to number of rows in the second matrix. Right? So this is the criteria to check we can multiply both matrices or not. So now the next one is matrix multiplication. For example, we have a matrices, a square matrices here, 3 into 3, A matrix that have the values A11 to till A33. Right? Similarly, we have the B matrices. So here is the pseudocode to multiply both the matrices. For matrix multiplication program, where we will multiply two matrices A and B, both are of order 3 into 3, and we have to store the result in the third matrix, that is C of order 3 into 3. So what we have to do, we have to multiply the first element of the first row of the matrix with first column, first element of the second matrix. Similarly, we have more multiplication for first row of a first matrix and first column of a second matrix. After that, we have to compute the sum obtained from the first element of product matrix. Similarly, compute all the remaining elements. So what we have to do, so we have to add in the last the all element. So that after that, we will get the next element, that is C11. So how many loops we require to multiply two matrices? How many loops we require to multiply two matrices? Just think about it.
I think two loop.
Three loops we want.
2 loop.
2, 3, okay.
Three loops. Three loops.
3 loops we require. Absolutely right. So this is the algorithm to multiply two square matrices of order n into n, where we have two matrices as a input and one matrices as a output, right? So here is the outer loop and here is the inner loop that will give the row and column, right? After that, here we initialize all the value of C matrices 0, because if we didn't initialize, the value is equals to 0, so it will take the garbage value, right? So that means the innermost loop is here, that will give the addition and multiplication of A and B in C, right? So this is the pseudocode, and here is the example. If we have a matrices A like this, B like this, and we have to multiply A into B, so we will get this matrix, right? So what is the complexity of matrix multiplication? You all know that how to calculate a matrix multiplication. You all know that how to calculate a complexity using loop. So just calculate the complexity of loop and give the answer. Akhil said n to the power 3.
N cube. N cube.
Anjali said n cube. Okay, n cube. Right. Because we know that there is always one unit for multiplication, for addition, for assignment operation, but here is a loop that is taking a value n times, and we have total 3 loops here. So that's why the complexity is n. Any issues till now?
No, man.
No one. Oh, God.
Thank you so much for acknowledgement. So you have to calculate the total complexity. You have to write each and everything. For loop will be execute n number of time in the first time. So that is big O n. After that, the second, you have to consider the second loop, and you have to write assignment statement inside second for loop will be constant time. So for that, we have to take a constant time, that is big O 1. Right? So the total complexity of this algorithm is big O n. Now the next one is exponent evaluation. Right? Exponent evaluation, that means we have a value with some power. For example, 4 to the power 11, 4 to the power 2. So how you calculate that? If I'm giving you a 4 to the power 8, how you calculate that? How do you calculate 4 to the power 8? That's my request to everyone. Please be attentive in
By
the class.
multiplying 4 8 times.
8
Yes.
times.
Yes.
Okay. Okay. So can we do one thing? Just multiply 4 into 4. We will get 4 to the power 2 answer. After that, multiply 4 to the power 2 times. We
Yes,
will get
Yes,
4
ma'am.
to the power 4.
Yes, ma'am.
Right? That means there is a less calculation when we do these kinds of things. Right?
Yes.
Right.
So this is the thing we have to implement in our algorithm. To create an algorithm that will take a less number of operations. So the idea of a binomial exponential, to split the exponent using the binary representation and then do multiplication. Right? So that we can take a very less number of operation and get a less complexity. That means log n. Because we are splitting our 4 to the power 11 into a very less number of operation. Maybe I have 4 to the power 4 answer. So I can multiply 4 to the power 4 into the 4 to the power 4 to compute a 4 to the power 8.
Yes,
Right?
yes.
So here is an example, 4 to the power 11. I can write this 4 to the power 10 and 4 to the power 11. And after that 4 to the power 8, 4 to the power 2 and 4 to the power 1. We have 4 to the power 1. We can calculate 4 to the power 2. After that, implementing this, I can also split this in 4 to the power something.
Why are you doing so, ma'am?
So repeat your statement.
Why are we doing so? Splitting the 4 to the power 11.
Because-
4 to the
Reduce
power 8.
Because-
the number
yes.
of multiplications.
Then we can
Yes.
do it by 4 to the power 4, 4 and 3.
Oh,
4 to the power 3. That means you have a 4 to the power 2 and 4 to the
Four.
power 1. So why are you calculating 4 to the power 3? So it's depend on calculation. If you are saying I can write a 4 to the power 3. Yes, because you have a 4 to the power 2 and 4 to the power 1. Right? So if you think I take this particular value and decrease the number of multiplication, yes, you can do that.
Okay.
Right?
Right.
So for that, the total, if we are splitting the numbers of exponent in number of terms, so the time complexity of this algorithm is log. So computing x to the power n, at some point x is equals to a. So we have exponent a to the power n. So we can split it using a method that is brute force multiplication of a. Right? So let's take one example to reduce the number of multiplication using binary exponential method to compute x to the power n. So here we have a binary string for exponent n to compute x to the power n. So we have a two method here, left to right binary exponential and right to left binary exponential. Let's take one example and do one by one. So first we are going to discuss about left to right binary exponential. Right? So in this method, we have exponent n because we are calculating a to the power n. A is some value, right? And n is exponent. So here we will proceed this left to right for exponent computation. So this is binary exponentiation. So for this, we need a binary number. So 1, 2, 3, 4 is a binary number. Can we write this?
No, ma'am.
No, absolutely. binary number is always represented in the form of 1 and
0.
1 or
Zero.
yes.
1 and
So
0.
let's take one pseudocode for left to right binary exponential. After that, we will take one example. So here is a pseudocode to compute a to the power n by left to right binary exponentiation. So we have an array A of size S. So let's take one array. The name of that array is A and the size is S. We don't know about the size, so we take as S here. So that array has a binary string equal to exponent m, where S is length of the binary string. So maybe 10010. So the length of this string is 5. So we can say S is equals to 5. Now the pseudocode first step is you have to set result is equals to A. So here A is a value. Maybe it's 2, maybe it's 5, maybe it's anything. Right? You have to set S is equals to S minus 2. Why we write S minus 2 here? We will see this in example. When we do example, when we take some binary value. So let's assume here we have to do I is equals to S minus 2. That means total length minus 2. Now the next one is you have to compute result. How you write a result? If I need 2 to the power 4, what should I have to do? That means I have to multiply 2 into 2 first. When I got 2 to the power 2 value, I just multiply again 2 to the power 2 value and got 2 to the power 4. So that's why they wrote here result into result and assign that value to result again. After that, here is an array. So array has some index. That index value is equals to I, that we already computed here. So if any array value is equals to 1, that compute result into A. See these two, third and fourth step. You have to calculate result into result. But when you found any array value is equals to 1, then you have to compute result into A, not result into result. Here I is equals to I minus 1. That means we have to decrement the value of an n. And if I is less than equals to 0, then go to the step 4. Right? Return computed value as result. So let's take one example to compute this. So we took one example here to illustrate the above algorithm to compute a to the power 17. So 17, which expression value is equals to 17? What we have to denote to give 17?
10001.
10001. Okay. So we have to calculate the exponent value as a binary string. So whenever we write a 17, we have to write 10001. This is a binary number for 17. We have an n value that is equals to 7. Right? So the total binary value is 5. So our n value is equals to 5. Till now, any question asked?
No, ma'am.
No, ma'am.
Okay. So according to our algorithm, we have to put we have to assign the value of A in result. So we just wrote result is equals to A. Now A memory location contain the value A. I is equals to S minus 2. So I is equals to S minus 2. So if we have an array of 5 elements, so we always represent the index value 0 to,
and
we have a 5 elements in an array. So what is
0
the
to n minus 1.
representation of index value?
That is 0 to n minus 1.
0 to n minus 1, that means 0 to 4.
Yes, yes.
Right? So we have to write S minus 2, that means 5 minus 2, because we are implementing this value. Where is the string value? Here. 10010. So the last value we have to skip and we have to implement the second last value. So here I is equals to 3. That means the result is equals to result into result. Result into result, that means A into A. We got A square here. Now we have to find AI is equals to 1. So I value is third. In third index, this is 0, 1, 2, 3. So here is the third index. Third index value is not equals to 1. Not equals to 1. That means we have to decrement the ith value. When we decrement the ith value, now the I value is equals to 2. Now we have to calculate similarly result into result. That means the result value is A square. A square into A square is equals to A4. Now again, we have to check arith index location second has any value that is equals to 1. No, that value is equals to 0, not 1. Then we have to decrement the ith value. So here I1 is equal, I is equals to 1. Again, we have to multiply result into result. That means A to the power 4 multiply the A to the power 4. That is A to the power 8. Now we have to check the ith location is equals to 1. No, it is equals to 0. Now I is equals to 0. Now result is equals to A to the power 8 multiplied by A to the power 8 is equals to A to the power 16. Now we have to check the ith location is equals to 0. Yes, it is equals to 0. So according to algorithm, when it is equals to 1, not equals to 0. So we decided here whenever we get any array location value is 1, we have to multiply result into A. So here it is A to the power 16 multiplied by A is equals to A to the power 17. It will give the result. So in this example, how many number of multiplication we use? Four. Okay.
4.
Akhil said 4.
Man.
4. But I think so.
No, 5.
Yes, 5. Because first we multiply A into A, then A square into A square,
Yes,
then A4 into A4, and then A to the power 8 into A to the power 8, 16. In the last, to calculate A to the power 17, we again multiply a single A value.
Yes,
Right?
yes,
Yes.
So, in this example, total number of multiplication is 5 instead of 16. Right? So, if we are talking about a complexity analysis, the algorithm perform either one multiplication or a two multiplication in each iteration for a for loop. So, it's depend on our computation. So how many loops we are using, how many multiplication addition we are using. So it is dividing our total multiplication values. It gives us a half value, half operation to calculate our result, right? 16 to half से भी half. So that's why the complexity of this is big O log n. Any issue for left to right? If yes, ask. Otherwise, I will proceed for a right to left binary experimentation.
Continue, ma'am.
Thank you so much for acknowledgement. So now the next one is right to left binary exponentiation. So if we are talking about this, so we have to proceed from 0th location. In the previous example, we are proceeding from the second last. Here we have to implement from the first location, right? So here is pseudocode. Set x is equals to a. If I 0 location is equals to 1, then set result is equals to 8. Else set result is equals to 1. Initialize I is equals to 1. You have to compute first x is equals to x into x. Then if ith location is equals to 1, then compute result is equals to result into a. We have to increment here I plus 1. If I is less than or equals to s minus 1, then we have to compute the fourth step and then return the result. So similar example they given here. Let us take an example to illustrate the above algorithm. Compute a to the power 17. In this exponent, n is equals to 17, which is equals to binary string 10001. Right? So we initialize a0 is equals to 1. So the result is equals to a. When we increment I is equals to 1. So the value of x is equals to a. We have to multiply x into x. So we will get a to the power 2. That means a square here. For the first index, the value is 0 because in 0th index we have 1. In first index we have 0. Then continuously 3 0 and then 1. So we increment the ith value. So here we multiply a square into a square, that is equals to a to the power 4. Again, the second location value is 0, that is not equals to 1. We have to increment our ith value and multiply a4 into a4. That means result into result, or you can say x into x according to this algorithm. So here is a to the power 8. Again, the third index value is not equals to 1. We have to increment the ith location and multiply x into x. That means a to the power into a to the power 16 here. So when we saw a to the power, fourth location value is equals to 1, we have to multiply by the result. What is the result? And multiply with the x value. So we got a to the power 17. Again, we got 5 instead of 16 multiplication here. So similarly, the complexity is log n. Any doubt you can ask.
No, that's right.
No, ma'am, thank you.
Okay.
No,
So-
got it.
Okay. So thank you for acknowledgement. Let's proceed for a next topic, that is a linear search or a sequential search. So let's start with this question. So what do you mean by a linear search?
Linear search is a sequential search where we start searching from
One after another.
to the nth element.
You said how we get a log. If you saw my loop classes, so you will get the log concept.
Yes,
So I
ma'am, but
think you
there
did
are,
attend that. So here if we multiply a to the power 17, we have to multiply a 16 times, right?
yes, ma'am.
And here we are doing the similar thing with 5 times. So log base 2 power 16 is equals to 4. Am I right, Mihir?
Yes.
Yes.
So that means it's compute you the log n time. Because here you got a 5 multiplication, and if you implement with log with 16, you will get a 4. So if that is near to the logarithmic value of 16. So that's why we write log n here.
Ma'am, but we have 5 loops, so won't it be log power 5, log n power 5?
No. Here we are multiplying 5 times, not we are using a 5 loop here.
Okay.
Right? So loop is
Sorry, repeat your line again. I missed due to the connection, bad connection.
okay, no issues. I said here we multiply a to the power n 5 times. That means 5 multiplication operation we use here instead of 60. Right? So if we are talking about a log base to 16, that is equals to 4, and we are calculating 5 multiplication operation, that is nearby log. So that's why we write a log n. If you compute using a for loop here, you have to jump it from 2 to 4 and 4 to 8. That means you are multiplying exponential power. So whenever you are getting a multiplication and division in your loop, instead of increment and decrement, you have to write the complexity log n. So maybe it's I multiply by 2, maybe it's I multiply by 3. So it's if you need to think about the increment and decrement, right? If there is multiplication sign or a division sign, just write a log n. That we already discussed in unit number.
Okay. So ma'am, in this case, it will be log n value will be log 5 or log 17?
Log 70.
17.
Yes, because n value is 17 now. So if you compute the 17 value, log base to 17. So what is the value for that calculated? This is 4 point something. Am I right?
Something.
Yes, ma'am.
So when we calculate the ceiling function of this, we will get
5.
5.
5. And here is how many multiplication we use?
5.
5.
Got the point?
Yes, ma'am.
So let's discuss linear search. What do you mean by linear search? What do you mean by linear search?
Searching an element in a sequence from a first element to the last element until we
Okay.
search that particular element.
So what do you think? What is the complexity of a linear search?
It will be in a 3 cases, ma'am. Best case, average case, and the worst case. If we if we find the element in a very first place, that is the best case. If in the middle, that will be average case, and if the nth element or not in the list,
It could be big O N,
it go N.
maybe ma'am.
Yes, absolutely right. So whenever someone asks you about the complexity of any code, any loop, just do remember you have to always calculate the worst case, not best and not average.
That will be big O. Upper bound.
Right? Yes. So linear search means that is a sequential search. If we have a list of elements and we have to find that particular search element in the list or not, we have to check each and every element with that search element, right? That is known as a linear search. So in this type of search, an element is searched in an array sequentially one by one. If match is found, then the particular item is returned and the search process stops. Otherwise, the search continues till the end of an array. So here is the algorithm. You have to initialize I to 1. If I exceeds the end of an array, then print element not found and exists. If I is equals to x, then print element x found at index I in the array and exit. So here is an example. We are given with a list of an item. The following table shows a data set for linear search. So here the key element that you have to search is 25. So what you have to do here? We have to check search element with 0 location to n minus 1. Right? So you have to search data key 25 and compare with first element, that is 7. They are not equal, then move to the next element in the list. And then key is again compared with 70. If it is not equal, then proceed till when you got the result. That means when both the element is equal, you have to stop there and return the location. That means ith location then. So you need a for loop for that, so that you can increment the index value and check your key with the particular index value. So again, yes, the best case is big O1. That means you found the first element in first comparison. Worst case, that means a very last comparison or no key found. And the average, that means a middle between the worst and the best case. So here is a two case. If item is present, then the worst case may be big O1. Sorry, best case may be big O1, worst case is n, and the average case is n divided by 2, that is equals to big O(n). But if the item is not there, all are big O(n).
Okay.
Now the next one is sorting. What do you mean by sorting?
Arranging in order.
Sorting the values in ascending or descending order.
Rather thandi mat. Okay, in order. That means arrangement of collection of data. Maybe it is in ascending or a descending order.
Yes, ma'am.
So we have some sorting techniques that is classified into two categories. The first one is internal sort. That means sorting algorithm in which the complete data set to be sorted internally. That means it is available in the computer's main memory. External sorting techniques are used when the collection of complete data cannot reside in the main memory, but must reside in a secondary storage, for example, on a disk. So if you read paging, so you understand these things. So how we take a data from a secondary memory to a main memory and then cache memory and so on, CPU can utilize that data. So here we have a bubble sort. So it is a simple sorting algorithm in which each pair of adjacent element is compared and exchanged if they are not in order. That means we have to use the adjacent element for comparison. This is not recommended for a bigger size array because its average and worst case complexity are of big O n square. Right? So this is an example. Let's take one example. We have to sort all the data in the form of a passes. So we have a first pass here with the element 23, 18, 15, 37, 8 and 11. Give me a minute, just give me. Okay, let's continue. So we have an element in first pass that is 23, 18, 15, 37, 8 and 11. So just compare 23, that means the first element, with the next index element. 23 with 18. Yes, 23 is greater than 18. So we will replace the both values. So 18 is here, 23 is here. Then 23, 15. So we have to exchange it. The 15 is here and 23 is here. Then again compare the third location value with the fourth. That means compare 23 with 37. Both are on the right place. Then compute 37 with 8. Right? So 8 is smaller. 8 is here. 37 is here. Then 37 with 11. So you can see here is the greatest value in the last. Now this is the first pass where we got a greatest value in the last location. Now compare the value 18 with 15 and so on. You will get the second greatest value in the second last position and so on. Just read this 5 parts.
Sorry, how it sorted actually confusing.
Confusing. Okay. I'm explaining it once again. So we have to compare the adjacent value. Right. So for adjacent value, we pick the first value, 23 and 18. So if we are talking about 23 and 18, 23 is greater than 18. Right? So we have to swap that value. My request to everyone, kindly mute. So 18 and 23 are swapped and both are on the correct position. Right? Smallest value 18 is in first position. Now we have to compute the second position with the third position. Second index, that means for this index value with the adjacent index value. So 23 and 15. 15 is less than 23. Now we have to swap both values. So 15 here and 23 here. Again, we have to compute the third position value with the fourth, 23, 37. So both are on the same position. Now we have to compute this value with the next adjacent location, 37 and 8. 8 is less than 37. Then swap the values. So 8 is here and 37 is here. Then again, you have to compare this value with this. Again, this value is less than this. 11 is here, 37 is here. So we got the last value is the greatest.
Got it. Thank you.
Similarly, you have to do this thing in the second pass. Again, compare the first value with the second last value. first value with the second value. That means adjacent index value. Then second value with the another adjacent value. So here 18 and 15. If we compare both the values, 15 is less than 18. So we have to swap it. 15 and then 18. Now compute 18 with 23. Both are on the right position. Then 23 to 8. So here 23 is greater than 8. Then we have to swap it. 8 and 23. Then 23 with 11. So 11 is less than 23. Swap the values. 11 here and 23 here. So you got 23, the second largest value on the second last position. Right? So we have total. So in this given list, divided into two sublists, sorted and unsorted. The largest element is bubble from the unsorted list to the sorted sublist. Right? So you will, if you have an n number of elements, you will get n minus 1 passes to sort your data. Here is total 6 elements. You will get 6 minus 1 passes. That means in a 5th pass, you got your answer. So these are the explanation how the pass 1 work, how the pass 2 work, and so on. You can read this from here. Okay, let's see this code. I'm giving you a 2 minute. Just understand the code.
कोई कोड समझा दो यार.
Is it stuck?
It's a simple to use here.
No, one thing I want to understand. The pattern of the code is like C or Python or Java, because I don't know any of the programming language.
Yes. So this is just like a pseudo code here. There is a no any programming language. So please neglect the syntax error here. Just understand the thing. That means here is a 2 loops. Right? So they are swapping the values one by one. So if we are talking about a first, so there is a first swap. So in a first swap, we are using all the index value of an array. So it will start from 0. So when we compute the 6 element, we get the passes n minus 1. That means 5 passes we got that time. So that's why loops start from 1 to n minus 1. So if you have an 8 element, you will get n minus 1 passes. That means 8 minus 1, 7 passes. For the first pass, when I is equals to 1, that means they are talking about the first pass. And for the
outer loop is for the passes and the inner loop is for the
array.
Yes.
Yes, array indexes. And after that, when you are in a first zeroth location, you have to compare that value with the next j plus 1 element. That means zero index value with the first index value. If zero index value is greater than the next index value, you have to swap. That means you have to exchange. Right?
Yes, ma'am.
In the one second. In array, how we correlate n minus 2 because number of iteration is less than 2 of n.
First of all, we are starting from 0. So if there is n element, we have a location 0 to 4. So here is n minus 1. And again, the last in the last, we got the correct value. So that's why we are not implementing the last index. So that's why there is n minus.
Okay.
So here you have to calculate the complexity also. So why this complexity they consider? Why they take we go and scare?
n minus 1 into n minus 2. Then the biggest value of n is n square.
Yes.
And into some constant value, and we have to neglect that constant value. That's
Yes,
why
ma'am.
here is n square.
Yes, ma'am. The biggest value of n is the n square in that statement.
So we completed with our unit number 3. So there is some check your there is some check your progress. So you have to try all the questions from check your progress. You have solution in your book. If you need any solution, just give me a question. I will definitely solve it for you. Okay, let's start the next unit. That is solving recurrences. Yes, Anjali, do you have any question?
No, ma'am.
Okay. So this is the last unit of this block. So what do you mean by recurrences?
Like how many times it is repeating?
Yeah, when any function calls
Itself.
yeah, one after
Calls
the next
itself.
calling is called recurrences. So yeah, like that only.
Have you heard about the substitution method, recurrence-free method, master method?
No, ma'am. Okay, we have heard about recurrence.
These are the key words which we use in mathematics, maybe substitution method like that.
Okay, let's discuss. Here is a method to solve a recurrence in term of complexity, right? So recurrence we use to reduce the TOC and to... Okay, what is the use of recurrence? It's okay, it's called itself, but what is the use? Why we use recurrence?
It will save the number of lines of code in some case.
And the result
It's reduced TOC, okay. Any other thing?
of when a problem is solved in steps and the result of the previous step is required to solve the current step, then this recurrence relation and solving are used.
Okay. Okay, whenever we have a smaller size of a data, we can use a recurrence. So it makes a recursive call to itself. Yes, you can save. You can say to save a memory. Okay. So we always use recurrence to describe the running time. So for a loop, we increase the number of lines also. Here is the single function that called itself many times. So that's why we are using a recurrence relation. So sometimes we said recursive function as a two types, one or more initial condition and recursive definition of a function. So when you studied about the functions, we always used to write function like this. So this is a recurrence relation in computer science. It's define you when n is equals to the 0, you get the value 0. When n is equals to 1, you get the value 0. But when if n is greater than n equals to 2, you get some function value and it's depend on your n. Right? So here is a Fibonacci series, that is f0, f1, f2 and so on. So here the basic step given in this series are: recurrence says that if n is equals to 0, then f0 is equals to 0. If n is equals to 1, then f1 is equals to, here is mistake in your question. It's okay. So here is the values where you have to implement. If n is equals to 0, you will get 0. If n is equals to 1, you will get always 1. If the n value is greater than and equals to 2, you will get this function value and it's depend on n. If n value is 2, you will get f2 minus 1. That means f1 plus f0. That means 1 plus 0 equals to 1. So this function values always depend on the previous values. So we have a method for solving recurrence relation. There are so many methods. You have 3 in your book, that is substitution method, master tree method and the master method. Master method is just like a pudding. You have to serve only it. Everything is cooked on front of you. Just take it and have it. So I'm not going to start in increasing order. That means the first in your book, the first one is substitution method, second one is tree method, and the third one is master method. So I'm not going to explain top to bottom. I'm going to explain this from bottom to top. That means I picked the first method, that is a master method.
What's the reason, ma'am?
Because there is only one formula. I already said this is a pudding. Everything is cooked in front of you. सब पका पकाया मिलने वाला है. You just need to insert one formula here only. So
Master means mama.
You can say.
Okay, ma'am.
Nice, bro.
So here is a master method. If we are talking about the master method, in this we have a function that is asymptotically positive if and only if there exists a real number n, such that fn is always greater 0 for all x is greater than n. we always define master method Tn is equals to AT n divided by B plus Fn. Master method is straightforward method. No need to do anything. Just remember the function, just remember the formula and do your question. Right? So, if we are talking about a master method, so this is a recursive function that gives you a running time of any algorithm that divides a problem of size n into a sub-problem of size n divided by b. So they use here n divided by b. That means here you divide a complete problem in this size. And a sub-problems are solved recursively in time n divided by b. So the cost of dividing the problem and combining the result of the sub-problems is described by the function Fn, this function. Right? So here is two things. So the recurrence is technically correct only when n divided b is an integer. Do remember this thing. May be integer. So you have to assume the value n divided by b is either n divided by b in floor function or a ceiling function. Right? So it's you have to take an assumption here. If you are replacing this with ceiling, someone replacing the value in ceiling function or a floor function, so it does not affect the asymptotic behavior of the recurrence. Right? You can take a ceiling value or you can take a float value. Right? So both are correct because here we are doing a assumption. But you have to think here, you always take a and b value is a positive integer value and n divided b is an integer value. So let's start the theorem number 1, master value, and these are 3 important cases. You always write your master value Tn is equals to a t n divided by b plus Fn, where a is always greater than and equals to 1 and b is always greater than. Right? And n divided by b. So this is the function for a recurrence. ये as it is रहेगा. There is a no change with this function. Right? For Tn, we have a 3 cases. If Fn is equals to big O n to the power log base ba. If you have to calculate this value. Right? And compare with Fn. If your Fn value is less than big O n to the power log ba. So you will get the answer theta n log ba. I'm rectifying this statement. So listen carefully. If Fn is less than big O n log ba, then we will get answer theta n log ba. If Fn is equals to theta n log ba, we will get equal. Whenever both the equations are equal, we get a solution n log base b multiplied by log. Next, Fn is equals to big O n to the power log BA. You will get a value. Here is not equal. Here is Fn is greater than this. You will get a answer theta Fn. This silence give me a vibes. That means you didn't understand anything.
Ma'am, if you give
Right, ma'am, you're right.
hey, what right, ma'am? Ma'am, sorry, ma'am.
Ma'am, please repeat, ma'am.
Ma'am, give an example also, ma'am. Along with explanation, just give examples also.
Yes, I'm giving example. Just give me some time. I am explaining all these cases. Don't worry, I'm giving one example of each case.
Thank you, ma'am.
So let's take one example. So this is example 1. Consider the recurrence of Fn is equals to 9t n by 3 plus n. So what is the value of A? Okay, first so the master's theorem equation. Before t, you will get a value of A. Below n, that means n divided by b. So this denominator value is the b value. So according to this function, we have A value. What is the value of A? 9. And what is the value of B? 3. And what is the value of Fn? So here it is. This is Fn. So the value of Fn is n here.
N.
Any problem till now? That means now we know A is equals to 9, B is equals to 3, Fn is equals to n. Now we have to calculate n to the power log base B A. N log base B. B value is 3 and A value is 9. So what is the value of log base 3, 9?
2. 3 raised to 2, 9.
Yes, absolutely right. 2. So that means the value of this equation is n square. यहाँ तक किसी को कोई भी doubt है? If you have any doubt till now, just ask. Because this is an important question and very easy question. You will definitely get a question in your exam from this method. Let me check the chat box. That means no issues.
Also.
Okay. Now we have to compute the comparison between two values, Fn and n to the power log base BA. Right? So the value of Fn in this question is n. Log,
Yes.
right? And n log base BA value is n square. Which one is greater?
N square.
N square is greater. So the value is theta n square. You have to pick the greatest value. In your book, here is mistake. This is Fn is less than big O and log base BA. This is equal and this is greater than. Fn is greater than. So if you have a greater value of any two number, the answer is that one with theta notation. Right? I'm giving you one more question here. Let's take यही एक example लेते हैं, but let's take this value as n square. So what is your answer?
If n is n square, if Fn is n square.
Leave that question. Do this question. B part. I need the answer of this question using a master theorem with explanation. A is equals to n square. A is equals to n square. How? A is equals to 4. B is equals to 2. Fn is equals to n square. So after implementing master theorem, what will be the value?
N raised to power 4.
N raised to the power 4. No. Any other answer? आप में से कोई समझाना चाहे? So
A is equals to 4, B is equals to 2, and Fn is equals to F is equals to n square. Then it will be written as Fn equal to n square the power log BA.
you are right.
Then n square raised to power 2, and the power 2, then it will become n raised to power 4 now.
Okay, let's take example here. 2 to the power 4 is equals to 2 square. No. N raised to the power 4 is not the right answer. Let's do it here.
Yeah.
So we have a value of A. A is equals to 4. B is equals to 2. Right? And Fn is equals to n square.
Yes, ma'am.
Now we have to compute n to the power log base b and the value is a. Right? Any doubt till now?
No, ma'am.
Because you have to understand these things also. Because this is the initial part of the explanation of this question. So that means here we have n
Square.
log base b. Base b, that means a 2. And the a value is 4. This is
4.
equals to n square.
N square, yes.
After that, you have the value fn
N square.
that is equals to n square. Now you have to compute both the values, fn value and n log base ba value. Both values are similar.
This one.
Whenever you got both the value similar, the answer is theta n, whatever the value of n log base ba. You have to write here. So that value is log n square here. And you have to multiply log n with it because the value of fn is equals to the value of n log ba. Right? So whenever you got fn is equals to n log base ba, the answer is the value of n log ba, that is n square, and multiply log n with it.
Okay, got it, mom, got it. वो केस देखना था ना.
Yes. If the value is n here and the fn value is also n here, that means again both the values is similar, but the answer is n log n. That means the value of this multiplied by log n. Yes, you said the right. Fn is equals to log base ba, but the answer is this. Okay, I'm not. I'm giving you the values here. If the fn value is n square and the n log base ba value is equals to n, so now what is the answer? This value is n. And fn value is similar, n square.
Then it would be n square.
Yes, it is theta n square. We always get the highest value. And if I'm taking this is n square and this is n, then what is the value?
Then also 3 times.
Theta n square. Absolutely right. We always take a greatest value. So this is case number 3. Before that, we implement case number 1, and before the first one, that is n square log when both the values are equal, that is case number 2. So I give an example from case number 1, case number 2, and case number 3. Any doubt till now, you can ask. Any doubt?
Ma'am,
Yes.
what is epsilon given in the formula?
That is some constant value you can reduce. There is no any impact on value.
Okay.
So there is no any doubt. Am I right?
Yes, ma'am.
So it's my request to all of you, start doing the check your progress examples or a questions. Right? So you will get good marks into your exam.
Okay, ma'am.
So we have half in our time. That means we can do one method more. So we completed our master method. Have you heard about substitution method in mathematics? Because tree method is too much long, so I'm not touching it right now. So let's start the substitution. So have you heard about this method in mathematics? I read it in class 9.
Yes, ma'am.
Yes.
So क्या करते थे हम इस method में?
इक्वेशंस को सॉल्व करते थे.
How?
दो इक्वेशन होते थे, उनमें से एक को x या y का वैल्यू को निकालते थे और दूसरे
वो
इक्वेशन में
substitute करते थे in the next equation. Yes, you have to do similar thing here, but there is some twist. Substitution is opposite of induction, right? We always start with n and move backward. So here we have to do two steps here, guess a bound and use a mathematical induction to prove your guess. So first one is guess the assumption bound of the solution, and the second is prove the correctness of the guess using mathematical induction. So solve the following recurrence by using substitution method. So here is n divided by 2. That means we are dividing our solution. So whenever we are dividing our solution, that is always give us log n times. मैंने पहले भी बताया. We always use log n whenever we are dividing. So we are dividing a solution and getting n as a function. So here we will get n log n as complexity. So we assume the complexity of this recurrence is n log n. You can use master method also to solve it. So if we calculate a master method on it, what will get? What will we get? बताइए.
N, ma'am.
N log n.
N log n, yes.
Yes, absolutely right. So we assume here this is a merge sort algorithm recurrence, and we assume that our solution is big O n log, right? So if we are talking about any function that is less than n, because we are using a big O notation here. So big O's function is fn is less than n equals to cgn. Cgn. So fn value is tn here and gn value is this n log n here. Right? So now we have, this is our step 1. That means guessing is our step 1. Now the step 2 is we use mathematical induction here. So in mathematical induction, first n is equals to 1. Right? We just put n is equals to 1. Here is 1, here is 1, and here is 1. Right? So log 1 is equals to 1. So here the t1 is equals to 1. Now for n is equals to 2, we have to put n is equals to 2 here. When we put n is equals to here is the value 2, 2 and 2 here. So when t2 is here, that means we have to put 2 here. So when we put 2 in place of n, we got the answer 2t, 2 divided by 2 plus 2. So here it is. less than and equals to, we said log base 2 and the value is 2, that is equals to 1. When you multiply 2 with 1, you got the answer, that is C2. Any doubt till now? Because we substitute t and value here. The t and value is this. Here in place of n we have to put 2. So that's why we write 2t, 2 divided by 2 plus n. Any doubt?
In next line, how capital T turns into small t?
That is printing mistake. No need to write small t here, just write a capital. That means no doubt.
Yes.
No doubt, ma'am.
And in next line, how T2 is 0, 2t is 0.
Okay. Just a minute. Okay, what is the value of log base to 1?
Zero.
0. So here is, you have to implement the value log base to 1, that is equals to 0. So here they implement the similar thing here. So that's why 2 multiplied by 0 is 0 here, plus 2, that is less than and equals to C2.
Got it.
Okay, ma'am.
While n is equals to 1, let's assume we got a value. Here we have T1, right? So here is something incorrect.
Printing mistake.
I have to do it once again. हाँ, यहाँ पर मुझे गलती लग रही है. I have to do it by myself. Then we'll give you a solution in the next class. Because if they got a value log base to 1 here with 0, so they should multiply this one with 0 also. Let me check. We will discuss this in next class. So substitution method and string method we will discuss in the next class. Right? So So we will discuss this in next class. Don't worry, I have to compute by myself. Then we'll give you the solution. Too important is to correct this conditions. So any doubt in today's class, because I'm not going to discuss a tree method here because it will take some time.
No, ma'am.
Ma'am, hello, ma'am.
Yes. ये बोलिए.
What is T here?
What is T here?
Yes.
T is used for a function just like Fn and Gn.
Okay, any mathematical function?
Yes, any mathematical function. Master method always used to write Tn because Fn is in the equation. So you can write Gn here, that, but they are mostly use Tn for master method. That means recurrence methods.
Okay, so it is some recurrence function, we can say.
Yes, we can say this is a recurrence function.
Okay, ma'am.
I'm giving some questions. So any doubt related to your assignment question? Or no one started yet?
Not started it, ma'am.
Not started yet, ma'am.
Also started here. Required more time than probably things.
So start writing your assignments.
Can we have any examples by which we can understand that in IGNOU how to write the assignments, right?
See, there is no any example for your assignment, but we can guide you how to write a questions. So this is just like just think this is just like your examination paper. You have to write the complete explanation according to the marks. If that contains 10 marks question, you have to write according to the 10 marks. If that question is 3 marks, you have to write according to the 3 marks. Right? Give underline to the important point so that the teacher interact with the important. Okay, when I explain the knapsack problem, that surely I will explain it in next class. So I will explain the knapsack instance also. So I'm talking about the assignments here. So that means you have to point out the important thing, underline the important lines, as well as give example, give a real world examples also. So after reading all these, the examiner can understand your knowledge, right?
10 mark question. You said that you should write accordingly the mark givens, right? So for 10 mark question, what we thought that how to write all this, how many pages?
I already given an example while explaining you a loop. So when I given you a nested loop question with some arithmetic operation in that loop, and said what is the complexity of that loop, you all always say n log n squares. But how we get that n square and n log n? That means we need explanation for that if that question is in 3 or a 5 marks, right? So there is a difference between you have to write 1 mark question and you have to write 3 or 5 marks question. If there is a 1 marks question related to complexity and there is 2 loop, you can always write the complexity of that loop is big O n square or big O n log n. But if it is in 3 marks question or a 5 marks question, you have to write explanation of each and every line. In first line, we have a complexity time this, in next time we have a time complexity this unit time, and in the last you have to compute all.
Okay, thanks. It helps.
Any other question?
I mean, exam like complexity questions will be more related to it.
It's depend on the person who is making your question paper. How to draw an adjacent graph. I will definitely complete this topic also in the next session. No, not next session, क्योंकि ये graph का part है. So it will be. It's a very, very, very simple question. If you have adjacent node, just give. If graph is given there, that means you have to create a list or an array. For each node, you have to, like for example, I have a node A, B, C, D, and E. A is connected with B, C, and D. That means you have to draw one by one. That means A connected with B, A connected with, in the next A connected with B and C, and in the next A connected with B, C, and D. So this is the way how you represent it with the each node. Right? So there is so many questions related to graph. For example, they will give a graph and say, kindly create a adjacent list or an array. So these are the questions. We completed the, I think so 30% of syllabus. Right? So there is, I think so 3 more classes we have. Am I right? 3 or 4 classes we have. So in that classes, we will discuss all the things.
Consulting the schedule is changed. So can you please share what is your schedule for coming week and months?
Okay, got your point. I will share in a group within today's Sunday. I will definitely share in Monday, on Monday.
Okay.
Ma'am, you also have a group.
You also have?
Means any other groups are also there?
No, there is one IGNU group now. You already there where you got your link.
Okay. Let me see.
MCS-211.
If you don't mind, can you share that link? Actually, I think I don't have that one.
From where you get this class link?
From the WhatsApp one in MCA.
Yes, that is the group. I'm saying for that, or only for that group.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Okay, so any other doubt you can share? Otherwise, I'm binding up this session.
Ma'am, please share some important question and solution in the for exam.
Some important
Question
question.
for the
So,
exam.
yeah, got your
Yes,
point.
please
First,
share our WhatsApp group. Yeah.
okay. So, firstly, do one thing. Check your progress. When you complete your check your progress, I will definitely share some important question or some other question so you can do practice.
Okay.
Okay, I am winding up this session because no other query. Thank you so much for attending my session.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, man.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
थैंक यू मैम चली गई भाई चली गई मैम
ठीक है भाई बाय बाय